large proportion of the students going into secondary education have failed to develop proper intuition for the concepts that they were taught in introductory algebra in primary. With this in mind, we're developing a foundational algebra course aimed at bridging the gap between primary and secondary. This table gives a clear idea of the material that would be included, as well as the overarching structure of the course. The focus is on developing intuition, rather than just getting students to be able to answer questions, as this will allow them to deal with more advanced concepts at a later stage. To this end, we're presenting the course in the form of an interactive app with a clear visual model and smooth animation to help strip away the abstraction and allow the students to be able to visualize the concept properly in their own heads. The model itself is an extension of the model method used by Singapore, but by adding animation, we can adapt this to be able to deal with more complicated algebra. They would start by considering the number line, and the first thing they would be asked to do is consider integer addition on the number line. Once they're comfortable with the way that this model works, we then introduce variables. The first thing you see is that there is a clear color difference. The reason for this is that we're trying to underline the fact that variables and constants are fundamentally different. We can go further than this by using the interactivity of the app to allow the user to tap on the X and then dynamically vary it. This would be represented by variation in the value of the overall expression on the number line as they're doing this. So again, it just reinforces the idea that the variable really is variable. For each of the concepts that's introduced, we would want a clear visual counterpart that encapsulates the defining characteristics of that concept. For instance, let's consider algebraic fractions. It's not enough simply to show the value of the overall fraction, because that doesn't really give you all the information. What we see here is that on the line, we have an expression that shows the value of the fraction. But when you tap on it, then above and below the line, we get expressions representing the numerator and the denominator. This means that when we're varying x, we don't just see how it affects the value of the overall fraction, but we see how that's dependent on the variation in the numerator and denominator respectively. We can also use this concept to aid us in asking the student questions. For instance, when solving equations, we can have two number lines, one representing the left-hand side and one representing the right-hand side. This will not only allow us to equate solving equations with balancing these two lines, but it will make the process of solving an equation more visceral by relating it to unraveling these expressions and ending up with just one orange line at the top for x and one blue line at the bottom for a constant. When we get onto Cartesian coordinates, we want to be able to relate it to everything that the student has learnt up to that point, so that it doesn't feel like it's coming out of nowhere. To this end, we'd start simply by displaying two number lines, one with a green line representing y and one with an orange line representing x, related by a simple equation like y equals x plus 1. As you vary x, you would see corresponding variation in y. Then we would combine the two number lines perpendicular to each other to create the plane, and there would be a single point on the plane corresponding to one of the coordinates of this line. As they vary x, the rest of the line would draw itself in so that they can discover the shape for themselves. In general, there would be a focus on the idea of experimentation and self-discovery. At the end of each lesson, the student would be encouraged to play around with their own equations and expressions in order to cement their own intuition rather than just learning what they've been told to learn. To this end, we would further incentivize the usage of the app by including some reward mechanisms, such as medals and trophies, in response to completing lessons and doing particularly well in quizzes. At the end of the day, we're hoping that this will enable students not just to be able to answer the exercises that they're set, but develop a firm basis for learning the rest of the secondary curriculum.